Okay, cool. So today we're going to explore Git and GitHub, which you've already been using a little bit, but I want to make sure that we talk about, really talk about it so that you understand what you're doing, so that you have some kind of pattern. I know a lot of you on your independent challenges might have gotten feedback that we'd like to see more commits or a different commit pattern. So we're going to talk about that and refer to it as your Git workflow. So that's what we're going to talk about today. So our learning goals are up. We want to talk about the difference between remote and local repositories. Okay, see. And then we're going to go through a sample like workflow where we'll create a local repo, we'll create a repository on GitHub, and we will connect the two and go through what a workflow would look like. We'll talk about branching today too, hopefully. There's a lot to cover, but I do want to start with a warm-up. Oh, and I also want to start my timer. Where's the other one? There it is. All right, so for a warm-up, what I'd like you to do is either in a notebook or on a text editor, whatever you're using for notes right now, take a minute to jot down what you already know about Git and GitHub. Maybe some commands that you're familiar with and what they do. Why do we use Git and GitHub? These kinds of things. So take about 3 minutes to explore your thoughts on those.
I hope you don't mind being on camera.
No.
You want to make sure you're muted too.
Oh.
It's all good. I just imagine that worst case scenario, you're having a really private conversation and you don't realize you're not muted. Take another 30 seconds to wrap up your thoughts. I guess I don't have to tell you to wrap up your thoughts if that bird tells you. All right. So, so let's talk just a second about why we use Git or GitHub. If one of you wants to raise your hand, and I'll call on you to just share your thoughts on why we even use Git and GitHub. Curtis, go ahead.
We use GitHub as we use Git as a version control system. So to kind of like create save points in our code base so that if we like break something, we can go back to a time when it wasn't broken.
Mm-hmm.
And GitHub is like cloud-based storage of your Git repositories.
Mm-hmm.
And it allows for like collective coding, so multiple people can work on pieces of the code at the same time.
Yeah. This is great. You just did all my bullet points for me. So thank you. I really like what you said too about collective coding, right? So think about like if you're on an engineering team on work and you've got this huge application and you need to work on one piece of it. Maybe you're like fixing the user interface so they can check out and buy things. But your coworker is working on, I don't know, changing the color scheme to work on the branding, right? So you both need to work on the same code at the same time. So pre-Git, you could only do this one at a time. Like I would have to do my work, finish it up, and then give it to you, and only one person could be working at a time. So with this version control system, it allows us, pardon me, to, and it's also called what's called distributed. Let me write that down. Distributed, which as the name implies, it means that this code base can be distributed to multiple people at a time so that I can do my work simultaneously as my coworkers doing their work, and then we can bring all those changes together. And so it's a great piece of technology to be able to do this collaborative or collective coding. And just as Curtis had mentioned too, it creates save points for us. And these are these commits that we do. And this is why we tell you to commit often, because it keeps a record of all of our commits. It's a little different than, I used to describe this as like if you're typing a Word document and you hit save, that's like a commit, but that's not accurate because on a Word document, when you hit save, it overrides whatever changes and just saves your latest drafts. So with Git, it's a little different. It saves like a checkpoint for every commit that you do. And so it keeps a record of like the transformation of the code, of the development of the code. So say like you've got some working code and then you go to work on the next method and you like screw up royally and everything breaks and you're not even sure how to rewire it to fix it, you can revert back to an old commit when everything was working and then start from there. So it's a really great place or a great way to save this code so that you don't lose everything if you accidentally delete everything. You delete a whole file. Questions about what Git is or why we use it? I'll say this about Git too, after George's question. Go ahead, George.
Yeah, thank you. People have mentioned this, like going back to different versions. I imagine we will be going over that onto how to retrieve that maybe in a different lesson or something, because
maybe.
I'm intrigued.
Yeah, we won't cover it today. And actually, I'm not sure if we have a formal lesson on that, but that's something we can explore. And once you start learning how to move around Git, that is definitely something you can Google. Git is much more than we will learn in Mod 1, and it's much more than you'll probably learn in Turing. But you can be very effective knowing even just a little bit about Git. I remember when I was first learning about Git, I was so confused. So it can seem very confusing and overwhelming, but once you get the pattern down and the flow down, because it is a little repetitive, then you can really start exploring how Git is working. But yeah, we can definitely explore that. Not today though. All right. And I was going to say something else. I don't remember. So let's talk about our Git workflow. So we talked about this commits. So commits is when we actually save some piece of code that we did. And there's a couple, this was an overview of what we just talked about. Sorry, I should have showed that while we were talking about it. So let's talk about our commits. There's a few different commit. What's the plural? Just an S. Okay. Thank you. The different stages of a commit. I don't like using that word because I'm going to use it again. But so your code can be unstaged, staged, and then committed. So there's different levels of this, and it might seem kind of confusing, but basically what it is as soon as you type some code, it's unstaged. Staged means Git is tracking this file, and it's like almost prepping your changes for being saved. And then committing is when we actually save it. So let's kind of see what this looks like real quick. So I've got a little planet class here, and actually just deleted some of it. So I have a planet test. Wait, I can't do this yet because we haven't initialized this. Okay, actually I want to do this so we can see an error. So does anyone remember the Git command to see, so that I'm trying to be very like cryptic with this, so we can see what we have going on with Git. Todd, can you repeat that?
I just Git status.
Yes, thank you. I was gonna say like the status of our Git, but I don't want to give it away. So if we type Git status, that will show us what we have staged, what's unstaged, what's committed. It'll give us all the information. But what's my problem here? Anyone know? It says it right there. We talk about reading your errors. Yeah, Joshua.
You haven't initialized the repository or the Git, I guess.
Yeah, exactly. So I haven't initialized this, my file here of Git1, my directory. I have not initialized it as a Git repo, which means Git is not even looking at this. It's not tracking changes. So here, let's do some important Git commands. We'll keep a list of these important Git commands. So our first one we're going to talk about is git init. Okay, and some of this might, nice dance moves, George. Some of this might be review from mod 0, so that's okay. The more you hear it, the more solidified this material will get. So this will initialize, oh, there's that hard word to spell, a local Git repository. What do I mean by local Git repository? And as opposed to what? Anyone know? Jake?
It's on your actual computer as opposed to like GitHub, which is the cloud or network.
Awesome, thank you. And Jake, do you remember what the other repository is called, the one that lives on GitHub, the website?
Like your master?
No, that's a branch. That's a kind of branch. George already knows it. George is playing charades over there. Jesse, what's the other one called?
Are you going for remote repository?
I am. Oh my gosh, this sounds like a game show right now. Yes, a remote repository. So local means it's living on my computer, which means no one else can see this repository right now, even though Git is tracking it. When it's on the remote repository, which is in like the cloud or the internet, it lives on that github.com, that's when other people can access it. Will, question?
Are all remote repositories always on the internet, or it can just be another repository?
Oh, someone is cracking up. You might want to mute yourself. I love the laughter. So great question, Will. It's always going to be in some kind of centralized location so that other people can access it. So typically on the internet, you know what, I don't know this for sure, but I can imagine that some companies have their own kind of internal system that you have to be part of that specific network to access it, but it's still going to be like a hub that stores all the remote repositories, so then people can pull those onto their local repositories. Awesome, great question. All right, so let's go ahead and initialize this Git repository. So if we do git init, great. Now you can see here that I've got, it tells me what branch I'm on, okay? And the first thing we actually wanna do, we wanna start getting into the habit of not using the word master. So we're trying to create, these inclusive environments, and master is not a word that accomplishes that. So we're gonna use what's called main instead. And my command to do that, hold on, I wrote it down because this is a newer thing for me too. Okay. And this, this command is in the lesson plan for this, but this will reset master to main. So I'll put it here. You don't need to like write this down right now. It is in the lesson plan so that you can copy and paste that from the lesson plan, okay? So this just reset my main branch from master to main. And we want to get into the habit moving forward as developers in Turing and into, you know, your communities when you get a job to really fight for using main instead of master. Cool. Awesome. So now,
Sorry.
Go ahead.
Could you say that one more time? I missed the difference between main and master. What was that?
So master is the traditional like branch where all working code lives. However, in an effort to move forward and create more inclusive environments, more equitable environments, we don't want to use the word master as it has some negative connotations. So instead, we want to shift to using the word main, which in my head makes more sense anyways. So main is going to be our like primary branch that holds only working code. And we'll talk more about branching and what that means, but main should always be pristine. It should not have bugs. It should always be working code. Zach, do you have a question?
Yeah, so every time we have like a new master branch, we want to rename it to main.
Yes.
And second question, we use the git symbolic ref head refs heads as our main name switching command. And then the last part is what we are renaming it to.
Correct. Those were the easiest set of questions ever. Okay, Curtis.
Is there a way to actually like change your default settings in Git to just like have it always create as main instead of master?
That's a great question. I would imagine there would be, but I do not know the answer to that question.
Okay, thank you.
Mm-hmm. Garrett?
Yeah, I guess two questions. So just as a follow-up to the main master piece, functionally they're the same. It's just main is obviously kind of a more inclusive way of describing what they're achieving.
Absolutely.
Okay. And the second question was, so at some point, I believe during mod 0, I essentially initiated Git at like my like root directory level. So like every directory that I create is like automatically tracked Git. Is that something I should look to change, or is that okay?
No, that's not okay. You don't want that. And it's actually a really easy fix. So when you do a git init, it creates a hidden file. Do you remember, and this is not just a question for you, Garrett, but remember hidden files, I changed my mind, I'm not gonna ask the question. Start with a dot, okay? And so to see that, the command in your terminal is ls-la, and then we can see that there's a hidden file called .git in this directory. If I rf that hidden Git file, now I no longer have a Git repository. So you'll want to go to your root level that has that hidden Git directory and delete it, and then it won't track everything. So, but that's a really good thing to note is you want to be inside the directory that you want to be tracking. So if I do present working directory, my PWD, I can see that I'm inside of my Git1 directory. This is, you know, the project that I am working in, and I've got files in there. So I need to make sure I'm inside that Git1 at the root of Git1 before I do my Git init. Otherwise, it'll start tracking more than just this project. Cool, great question. So now let's type Git status to see where we're at. So I did add some code before this lesson so that we could see this. So we can see we have our untracked or unstaged files. Just means Git is like, hey, I see you've got these things here, but I'm not watching these. Do you want me to? So to our command, and I'm gonna go a little fast through this piece because I think you all learned this in mod 0. So what I wanna do, actually, let me first show you. Now I want it to track, so I want to stage it first. So let's stage this. So I can do git add, I can do lib notes.md and test. So you can list out multiple things all at once. There are some other shortcuts like git add dot will add everything. I prefer to be a little more explicit, but for sometimes when I'm going really fast, I'll do the git add dot. Okay, but that will move these files and directories from unstaged to staged, and that means Git is tracking them. So now if I do a git status, they are green, and they are in, they're being tracked. It says changes to be committed. Okay. And so what I have here is I have a working test, or well, it's a failing test. It fails, but it works. Like it tells me my code does not yet do the things I want it to do. Actually, that's not true. Let me do this. Let's pretend this doesn't exist yet, right? Because in true TDD, we have our test. We don't have the code yet that makes that work. So if I do Ruby, what is this file called? Planet test. Cannot load such file. That's not the error I was expecting. Oh, whoops, I forgot to change my master also again, since I deleted that repository. Let me do that really quick. Okay, and then it shows that I am on main. Oh, yeah. So let's add my lib planet.rb so that it is being tracked to git status. Cool. So I always like to do git status to know where I'm at and know what I'm doing. And then what I'm going to do is I've got this test. So I want to document my TDD. So I'm going to commit my test. My test is good. So let's do git commit. Oh, maybe I don't want all of it. That's fine. So git commit -m, and then we want to add a message that's descriptive of the functionality that I just put in place. So right now I did adds test for planet class. Okay. So let's add that to our notes for important Git commands as we have our git commit. You always have to leave a message for a commit, and it should be descriptive of the functionality that you are adding with that save checkpoint. So message describing oh my gosh, I can't spell today. Is that right? That doesn't look like a word. Okay, Will. Sorry, Curtis first. I'm sorry. Give me 1 second, Will. Curtis?
So I've been like going back and forth with myself on my commit messages, like on the War project. How specific is too specific? Like, do you want to include like the file that you made the changes in? Do you want to?
No, because part of your commit message is going to show what files have been changed. So you want to keep it short and sweet, but also descriptive. So that if you are looking back quickly through these commit messages, you can say, okay, where was it that I created this method? So a good workflow habit to get into is once you have a test that you're happy with, make a commit that you added the test. And then once you write the method that makes that test pass, go ahead and do a commit for that functionality, for that method. And that will document your TDD because you'll be able to see the order of commits that you wrote a test, you did the functionality, or you wrote the method, test method.
Okay, cool, thank you.
Yeah, Will, go ahead.
Yeah, my question is sort of similar, and kind of Aiden touched on it in the chat a little bit, but in Mod 0, they told us that our commit messages should be in sort of the command form. So like instead of adds test, which I actually really like the message you have here because it just makes some sense to me intuitively. It should be like add test, and I'm like getting frustrated with my own commit messages because I'm like, I don't want to use the command form. It's not very clear to me. But is there a standard and strong recommendation for one versus another?
I think my answer will be it depends. It will depend on wherever you end up working, what they prefer, because they may have a preference and you'll need to follow their guide to keep consistent. For me, I would say like my personal opinion, which you'll hear a lot of personal opinions through your coding career, is I like the adds test because it said, what does this commit do? It adds the test for the planet class. I could see like the command one too. I mean, I guess that would just be add test for planet class, but I don't know. I don't think it's that much of a difference as long as you're being descriptive and we can tell what this commit's doing. Who asked that question? Was that Will? Okay. Taylor, go ahead.
Sorry, I had myself muted. Sorry if I missed you talking about this, but in a situation like this where you're making like a commit that changes multiple files, would you write like add test, update, planet, class?
This is a really good question. And the only reason I have so much here right now is because I did some stuff before class. But yeah, no, you would want to do this in separate commits if that's the case. You really want commits to be very focused on this piece of functionality. So you wouldn't want to have like, I mean, it's possible like because I can imagine once you get more and more classes that to make a method work in one class, you might have to make changes in other classes. And that could still be one commit because you're making a change to accomplish one piece of functionality, even though it changes multiple files. That's okay. So think more about like encapsulated functionality. Like what's the focus or the goal of what I'm working on right now? And once that's achieved, let's make a commit for that.
Okay, yeah, because I've been doing a lot of like kind of what I just said. I would do like for a project, I've been doing like update, planet RB method, and add test for planet test or whatever. But you're saying it should just be more focused than that.
Yeah, you wouldn't just want to say like updates class because that's not very descriptive. Like what does it do?
Okay. Thank you.
Yeah. Aiden?
Yeah. So to touch on what Will and you, Kat, we're talking about, the way I think of it is I think in my brain that I want to be able to use the commit message as the continuation of the sentence. This commit will add something or other. So that's the way I think of it. I don't think of it as a command. I think of it as what it would do if you used it, if you just put it in on top of the other commits, which is what you're doing. So.
Yeah, awesome. I love it. That's a good way to think about it. And then go ahead, Joshua.
To kind of go off what Taylor was asking. So in order to do that, would you have to stage the files one at a time? Or is there a way to commit specific files? So, okay.
Yeah, no, you would have to stage them. So you could, if you had say you were working for like 30 minutes, you're like, oh shoot, I forgot to commit. You can go through and just stage specific changes. If we have time, I'll show you that, but you can stage specific changes and then do a commit and then stage the next set of changes and do a commit. But yeah, you'll want to group them together by functionality.
Okay, thank you.
Connor?
Yeah, I was wondering what might be the best practice for committing with a message on multiple files where maybe one file you maybe changed like a letter in it, and it picked it up or something as a change on Git.
Yeah.
When you recommit those, like...
I would say for like little things like that you catch, like a spelling error or a syntax error, I would just group that in with whatever you're working on.
And it's not a huge thing. They don't. Okay.
No. So yeah. All right. I'm going to keep moving on because we still got a lot to cover. So let's do our commit. And now if I do a git status, we made some changes in the notes. So that's unstaged, but the rest of everything is ready to go. So here I can do it for this one too. Let's add our notes.md. If I do a git status now, I see it's green. And then we can do a commit to say like, what did I add? Adds more Git commands, I think is what that one did. And now Git status. Okay, so on branch main, nothing to commit, working tree is clean. So now what I need to do is I need it to get from my local to my remote repository so that all my coworkers can see the code that I've been working on. But actually, I'm not going to push yet because I didn't finish my functionality for that test. And maybe I want that to be all in one push. And so this should actually create the class. let's see if my test fails. I'm gonna, yeah, see, it didn't see my file. I think oh. Okay, so now my test passed. So what I'm gonna do is, now that my test passes, I wrote the method, or I wrote the code that made my test pass, I'm gonna commit that now. And since I did, this is kind of going back to what you were asking, Connor, I think, is, you know, I had a little syntax error, which I should have caught on the first time. I should have caught that on my test, but I was rushing through. So I made that change so that my test was actually functioning. I had a syntax error. I'm okay with that being committed together because it's still working towards accomplishing making this planet class. So I'm gonna git add these two things. I'm gonna check my status, right? So you can like add everything inside of a directory by doing it like that. And then I'm gonna git commit. We're gonna say this is adds planet class. Cool. So git status, I hear my bird. Okay, so this is actually a good place to maybe pause and take a quick palm, and then we'll come back and push this from my local to my remote repository, right? So let's come back at 1:36. All right, is my screen still shared? Can you see my screen still? Okay, thank you for the nods. All right, so, okay, so we're fully committed. We're ready to get these changes up to our remote repository so our coworkers can start working with this. So here's a really helpful Git command if you don't already know it. It is git remote-v. I'm going to put that in our notes. So what that does is it lets us see if we have any remote repositories linked to our local repo. Right now we do not. There would have popped out with something. So that means if I try to do a git push origin main, it's gonna say, yeah, there's no origin, like I don't know what you're talking about, because it's not linked to anything. So what I need to do now is go to my GitHub, make a new repository. And again, I'm going to go through this piece a little bit faster because I think you're familiar with this piece. So let me know if you have questions. So I'm going to call this Git practice lesson. Okay. And we'll make it public. We'll create the repository. And then we can just copy this line, the git remote add origin. So git remote add is that command, and then what are we naming the link? We're naming it origin, which is pretty customary to name it, or conventional to name it origin. You could technically name it whatever you want. I could call it banana if I wanted. So it would be git remote add banana. And then whenever I wanted to push, I would do git push banana main, right? So you could call it whatever you want, but no one calls it banana. So just call it origin. Don't set yourself up for failure. Okay, so, and then this is the location of where this repository lives on GitHub. So it's the remote location. Okay, so I'm going to go back over here, I'm gonna add that. So git remote add origin, and then the name of my remote repo. Now if I do git remote -v to check if I have anything linked up, I can say, yes, I do. So it's called origin is the name of it. And this is the location for fetch, location for push. Usually they're the same. Cool. So now I'm ready to go from my local to my remote. So I can do a git push origin main. And it should do. Yep. It's pushing up all my changes. And now if I'm back on my GitHub repository, I can click on code and I can see my changes. Because this was on the main branch, I'll set as default. Because it's on the main branch, there was no like merging or anything. It just automatically merges it. Okay, so all that kind of should have been review, I think, which leaves us 20 minutes to get to the new stuff. So let's go. We want to talk about branching. What is a branch? Why do we branch? Remember, main should always have our pristine working code. So right now my test passed, so I know main right now is pristine and working. So let's say the next thing I wanted to do is add another piece of functionality to my little app here, my little Planet app. And what do I want to do? Oh, well, I want to give it some methods so I can read its attributes, right? So I'm not going to do this on main. And this is a really good practice to get into whether you're working solo or not. Well, definitely you need to practice this if not working solo, but even if you're working solo, you want to use this branching workflow. So a branch is kind of like, if you can see my hands, I'm going to do some movement here. So if this is main, branch is going to come like literally branch off of main, create like a copy of main that you can start working on, but your commits and changes on this branch do not affect main, not until you tell it to. So your branch is like a safe place to work on some code or add some methods, and main will stay in a pristine working condition. So with your branches, you want to name them something, just like your commits, you want to name your branch descriptive of the features that you're trying to add or the thing you're working on. So maybe here I want to, well, our commands for doing a branch, and please raise your hand if you have questions, because I'm going to power through this a little bit to make sure we get through it. So please raise your hands if you have questions. So our command for this is going to be git branch, oh gosh, dash, why can't I remember it right now? I'm on the spot. Because I can make a branch, but I want to check it out at the same time. So it's -b, and then the name of the branch. So I'll do name of branch so that you know that this is the piece that's dynamic. Okay, so here, right now I'm on my branch main, and I want to do a git branch -b, so that -b will create the branch and move you to the branch all in one command. So I want to do a git branch b. What am I going to add? I'm going to add planet, or I'm going to call this planet attributes as the name of my branch. Uh-oh, why didn't that work? Oh, whoops, just kidding. I told you the command wrong. It's git check out -b. So git branch will show you the list of branches that you have right now. Check out moves you to a different branch. So I apologize, I misspoke. The command to create a new branch and move to it all at once is git checkout -b, and then the name of the branch. So I'll call it planet attributes. There we go. So now it moved me to this branch of planet attributes. And if I do git branch, I'll be able to see all the branches that exist. So I see I have a main branch and then planet attributes, which is starred. It means that's the branch I'm on. So now I'm in a safe place where I could like completely screw everything up, but main is still protected because I'm on a branch. Okay, so now we would go through our, Garrett, go ahead.
Yeah, so and maybe you're getting this, or perhaps I missed it. I guess what's the purpose of a branch? Like sounds like it's so we can keep our main our main branch or our main our Git main clean. But like as far as like when we'd use a branch, like when are we using your branch versus not using a branch, or
Yeah, great question. And you're completely correct. We work on branches so that we keep main clean, and we work on a branch anytime we want to do additional work on main. You never want to work on the main branch. So if you remember at the beginning of this lesson, the first things I did was git push origin main. That's actually something you don't want to ever do unless it's the very first commit to establish, or the first push to establish your remote repo. Then you want to get into the habit of every time you add a feature, add a test, add a method, you need to be on a branch so that you're not at risk of ruining your main branch.
So every commit will be either on a new branch or on like a similar themed branch that we just created.
Yes, so every commit will be on a branch, and then we will push these branches and merge them into main. Yep, but a branch can have many, many commits on it, right? Because it might take me a while. And so while you were kind of talking, I added this test real quick because this is not a TDD lesson. So I just powered through that, added a test to make sure I can have a method of .name and .order. I want to run my test to make sure, oh, thank you, autofill, to make sure that my test actually works correctly. Okay, so I have no syntax errors. I just see that my test is failing because I haven't written the code yet, but my test works. So I'm going to commit at this point, since I have a working failing test. Does that make sense? Like not a broken test because of syntax. My test works, but it's failing. So that's good. And then so I'm going to get add, I'm going to use the shortcut, git add dot, we'll add all those things. I always like to check my git status to make sure everything was staged properly. And then I'm going to git commit and say adds test for planet attributes. I always do, I got in this habit, I do git status all the time just to make sure what I wanted to happen actually happened. I feel like I'm on like, 2x speed right now. So I apologize that I'm going so fast. I just want to make sure you get this content. Remember, this is recorded. You can play it back at like half speed so that I don't talk so fast. Great, so to get this working, I'm going to add my methods via my attr because attr adds methods by these names, right? So name and order, I should have those methods that exist now. Run my test. Test is working, so we're good to go. So I'm going to do my whole workflow again. So I'm going to git add that. I want to git status to check, make sure it's staged. I want to commit it with the message that says adds name and order methods. Cool. Git status. We look good. Okay, this is the part I really want to show you about merging. Okay, so this branch is good to go. I finished all the features I needed to do. Maybe you're actually doing a little more on the branch, but for the sake of this lesson, we're only going to do these attributes. So I need to push this branch up to my remote repository. Now it's not going to automatically put it into my main. I have to tell it to do that. So I'm going to do git push. Where do I want to push it to? It's the name of the remote repository is origin. But then here I do the name of my branch because that's what I'm wanting to push up to my remote repository. So my branch is called planet attributes. Okay. Do I want to show a, okay, no, this is fine. Taylor, go ahead.
So if you're on the specific branch, can you just run git push without the origin, or will that push, or will that mess things up?
If you've set your upstream with that -u command, you can, but I think that upstream is set. That's a good question. Yes, you can, but I always like to be very explicit about what I'm pushing up. Actually, I don't know the answer to that. If you just do git push, what would happen? We can explore that later.
Okay.
But you want to tell it where to go and what you're wanting to push up. Connor, go ahead.
So git push set upstream origin, your branch name basically does the exact same thing, right?
Yes, but then, so with that -u, that sets the upstream so that you don't have to type it all the time. Then you can just do git push. So I'm pretty sure it just sets the upstream, and then whatever you're on, that goes up. But again, I like to be very explicit in my practice, so I don't use a lot of those kinds of shortcuts. But you definitely can, and if you feel comfortable with it, go for it.
That's just what was suggested from what was previously asked. When you just do git push, it tells you type this command. So
okay, so it's telling you to set the upstream. Okay, that makes sense. Cool. So
Thank you.
Yeah. that month's my 10-minute ding timer. Okay, so now when we go back to the remote repository, we see here that, oh, a branch was pushed up. So we want to do what's called a pull request. Now the naming is a little funny. Other websites that host these repositories, because GitHub's not the only one, there's like GitLab and Gitbucket or Bitbucket, there's different ones. So it's not always GitHub, but GitHub's terminology, it's called a pull request, which is a little like, we're not actually pulling, it means like a merge request. So we want to get our branch and push it into master so that master is updated with our new feature or our new methods. So what we're going to do is a compare and pull request. And we can leave some comments here about what it does. But if your commits are descriptive, you don't have to leave extra comments here, because here we can see in my commits, it shows exactly the work that was done. Okay, so what we want to do is create a pull request. We'll get to Git for pairs next week. So for now, it's okay if you create a pull request for you to merge it. Okay, so there's no conflicts, which means if I merge this, it's not going to automatically break main. It could still break main. That's why we always test and review our code, but it won't automatically do it. So since this is green, I can merge the pull request, confirm. There's a lot of steps because you're pulling this into your master branch. I'm sorry, your main branch. Great, so it says that I have merged 2 commits into main. So now if I go back to my code, this should be updated. So let's take a peek in lib in my planet. And yes, I can see my adder readers were added. So on my main branch now, say I'm on main, my code is updated. Okay, then the next challenge though, right, is, what do you think? Like, is my local main updated? Ooh, people are shaking their heads. I like that. Good. So our command to get, we're done with this branch. This planet attributes has been merged. It is now a dead branch. I never want to work on it again. So I need to move back to main at this point. So we're going to use the command check out. Git check out, and then branch name. So notice this one does not have the -b, so it's not creating a new branch. We're just moving or checking out the other branch we want. So we want to do Git Check Out Main. That will bring us, oops, I have some changes. Obviously, I just added that in my notes. Oh, that's annoying. I'm gonna just do something. Don't worry about that. I stashed my changes, so we don't have to worry about those right now. Don't worry about that right now. Let's get back over to main. So Git Check Out Main. So now I'm on my main branch, and if I look in my planet.rb, my adder readers are not there, right? Because my local repository, main branch, has not been updated. So the last step in this whole workflow is to now update my local repository, update main with the updated code from the GitHub repo, from my remote repo. Okay, and the command to do that is git pull, because I'm not pushing it, I want to pull it into my local, git pull origin main. And let me bring this up so we can see what happens. So now when I press enter here, see how it added my adder readers in my text editor? So it pulled down all the changes from the remote repository, and now my local has the most up-to-date branch of main. Connor, your hand is still up. Do you have a question, or is that from last time? Okay, I can read your lips. All right, so now I'm free to work on my next feature. Okay, and this is the Git flow cycle. So let's kind of write out this Git flow cycle. So Git, it's called workflow. I'm not sure why I was calling it Git flow cycle. Words. Okay, so what we want to make sure we do first, pretty much, is update our local repository. And so we'll do that by running the command git pull origin main. So that's kind of always your first step when you're ready to start on something new. And then the next step is what? We're going to work on a brand new feature. What's my next step in my Git workflow? Maybe we're going to add some sun classes. Carson?
Git Checkout branch.
Yeah, so I need to make a new branch to work on to create my new feature. So yes, that command was correct. So let's do create new branch to work on. And we'll do that with Git Checkout -B and then the name of branch. Okay. And now we just do work. and your process will be git add and git commit, repeat. Right? So now you do the workflow that documents your TDD, creates the test, creates the method, creates a test, creates a method. And then when we're ready to go, say we're all done, we're happy with our feature, all our tests are passing, I'm ready to push this up and get it working. What's the next step? Taylor, are you raising your hand for a question, or do you want to provide the next step?
It was a question, so I'll just wait until we get to that point.
Okay, thank you. Who wants to tell me what the next step is here? So I'm on my branch. I have completed the work that I want to do. I've written all my tests. They're passing. All my methods are passing. So what's my next step? Jake?
You push to the branch?
Yes. So, well, we push the branch to the remote repository.
Yeah.
Yes. So push local branch to remote repository. And our command for that is git push origin branch name. Okay, awesome. What's next?
You forgot to put the little closing bracket on there.
I sure did. All right, what's my next step? I just pushed up my local branch to my remote repository. Now what do I need to do?
Come to think of it, you did that above too.
I must not like that symbol today. Zach, go ahead.
I make a pull request?
Yes. So go to GitHub remote repository and make a pull request. Sometimes we call them PRs. Actually, a lot of times we call them PRs. Right? And that you just do using that GitHub interface. And it's just pressing all the buttons. Okay, so say we did that, we merged it into main. What's the next step? What is the next thing I need to do? Kate?
Check out the branch on your local machine.
Which branch?
The branch that you just merged into. So the branch that you just did a PR on and merged into main.
Mm-hmm.
You're going back to your machine and checking out to get it to get back to main, basically.
Okay, yes. So I want to go back to main. So which means I'll want to do the command git check out main. Right? Because if I just pushed my local branch, then I'm on the branch of like planet attributes. So I pushed that up, I merged it on GitHub, and now I want to leave this branch. So I'm going to do a git check out main to come back to the main. And then what's the next thing and last thing that I do?
Yeah, does it Git Check Out Main or Git Check Out Origin?
It's git check out main, because origin is the name of the link to my remote repository. Main is the branch I want to move to.
Nice.
Mm-hmm. And then George, what's the last thing I do here?
Git pull origin main.
Yes. So git pull, and what does that do? George, what does that do?
Sorry, it changes your local repo to be your most updated with the merges that you had created on your secondary branch.
Yep. So it updates our local main with the changes from the remote repository. And we do that by doing git pull origin main. And now we do this whole cycle again and again and again and again. So this is the workflow that you need to get really comfortable with. Even while you're working on your solo projects, you probably haven't been branching thus far, but I do encourage you to start that branching today. The more comfortable you get with GitHub, well, you're going to be using it for the rest of your dev career. So you want to get comfortable with it. Okay, and we are right up at 2 o'clock. So are there any final questions on this workflow? Go ahead, Jose.
Yes, I have a question. I was for the project you're doing for the war piece. I noticed I read it yesterday that I was looking at the rubric, and it said that we have to have at least 30 commits and 3 pull requests. When I did it, I had 19 commits, and I thought I was doing good, but I figured out why, because I kept committing. I did the test, then the code, then I committed. Then so I noticed because of that I should do one at a time. But the other thing is, how do we know when to do like a pull request? Because it said 3, but I had around like 19 pull requests. Because what I did the test, the method, and then I did a pull request.
Yeah, so think about it like the branch should be a larger feature you're trying to accomplish. Like maybe the branch is adds functionality for building a deck or something. And so in adding that functionality, you might have lots of commits, like 15 commits on that branch. And then when that piece of functionality is done, then you push that up for a PR. And then once that's good, then you branch for the next chunk of functionality. So you do have to get in the habit of like, I don't like how I'm going to say this, but chunking out your work or breaking it up into sections so that you can work on that piece and then push that back up.
Okay, yeah, because what I did is for every method and test, I made a pull request.
Yeah, so that's too many pull requests. You'll want to have, those should be commits on a branch that's encapsulating a larger piece of functionality. All right.
Okay, thank you.
Taylor? Taylor, Cheryl, and then we got to stop.
Okay. So are you always going to be wanting to pull in the main, or if you're like, I'm just thinking to like when you're working in pairs, if like, are there times where you will want to be pulling on down the branch that you're working on instead of
Yeah.
the main?
Yeah, definitely. If you need to collaborate on a branch, but we'll talk about that. We're going to do Git for pairs next week.
Oh, okay. Okay. Thank you.
Yeah, Cheryl?
Yeah, I was curious why you don't store it locally and then push it. Like, why would you push it remote and then pull from there?
For like this branch?
For just branching in general, like instead of doing it on your local machine and then, you know, pushing it as you go. I don't quite understand that.
So that's
that
just,
makes sense.
well, we wouldn't create the branches on the remote. Like we only do the work we need to do at that moment in time. And so on our local machine, we want to take, because main holds all of the working code, right? So we want to have that on our machine updated. And then we do our job. So what if your job is to add the deck class or the whatever, then you get to make a branch and just start working on your local, because maybe like you hate everything you do and you break everything and you want to just toss your branch out. We don't need a record of it at that point. And you could start a new branch. And then once you're, okay, I hope that helps a little bit. Okay, awesome.
For my clarity, follow up on that, is it fair to say that basically we should think of that remote place as really that's the true master location?
Not necessarily, because you might have like a branch you're working on and it's in progress, but it's not completed. And you could push it up to your remote in case like your laptop dies that night. It's stored on the remote, so you can then get a new laptop and work on your in progress branch from a different local machine. So it's not necessarily, I mean, it will hold main, but it will hold other things too. Okay, we're definitely over. So I'm going to go ahead and close this out. Thanks for being here, and then check the